Hi, good morning everyone. To my fellow viewers, my name is Sujay from Sarawak, Malaysia. Today I will be presenting on my poster that is specially made for 32nd World Congress of Soil Science that held in Glasgow this 1st July until 5th August 2022, which entitled of effect of liming on the copper, zinc and boron uptake and oil palm growth in tropical peatland. For introduction, tropical peatland is phenolic rich due to accumulation of the organic plant material in waterlogged condition, which result in the acidification of peat soil. Peat soil acidity results in yield-limiting factors that affect the crop production due to the decrease of availability of micronutrients, particularly copper, zinc, and boron. These are type of essential micronutrients for the crop production and plant reproductive growth. Liming application has been a standard practice to reduce soil acidity and to improve soil fertility. However, due to the high buffering capacity of peat and lacking information on the optimal rate of liming, there has not been a systematically practice on liming on a big scale of all palm plantation. There is two objectives in the study. The first one is to systematically evaluate the effect of different rates of liming on the soil pH, copper, zinc, and boron. And the second is to determine the optimal rate of liming on the peat soil. These experiments were conducted at the oil palm plantation in Cebu, Sarawak, using four different types of treatment, which is control treatment 1, 2, and 3, which refer to 0, 3, 6, and 12 tons per hectare per year, respectively. In this study, liming was applied once a year for the first 2 years of the experiment, which is in June 2017 and 2018. Peat soil samples were collected quarterly every year at the depth of 0 to 25 cm. This soil sample were analyzed to find the soil pH using method of suspension of soil mixed with the still water at ratio 2 to 5 using pH meter, and for available soil nutrient using 0.1 and hydrochloric acid extraction method. Besides, plant samples were collected twice a year and analyzed for the micronutrient analysis using acid digestion method. Both of these samples were run through the ICP OAS. As shown in Figure 2, the trend shows the increasing pattern since July 2017 until March 2020 before the decrease to December 20, and the pH value were recorded throughout the experiment were in the range of 3.55 to pH 4.0. According to Abad et al. 2012, the decrease of soil pH after March 2020 suggesting that the release of the hydrogen ion associated with the soil organic matters in the peat soil, which meant that peats become more acidic with time from the effect of the fertilizer and so on. As shown in Figure 2 and 3, the soil availability of the copper and zinc was enhanced with the increase of soil pH, especially for treatment 2 and treatment 3. The enhance of the soil availability of micronutrient with the increase of soil pH observed in treatment 3, probably due to the decrease in competition of the hydrogen binding sites and the increase of the negative charge of the peat surface. In this graph, treatment 2 shows the highest of micronutrient content, especially for copper and zinc. This is likely due to the increase of the CEC, which depends on the presence of pH-dependent charge in the soil and decreased competition with the hydrogen ion for the compensation onto the soil organic matters. As for table 3, soil pH had increased the CEC, which may due to the dissociation of the hydrogen ion from the weakly acidic functional group from organic matters. The dissociation of the hydrogen ion decreased the competition of the hydrogen binding sites and increased the negative charge of the peat surface for the absorption of copper and zinc. As shown in Figure 4, soil available copper and zinc were positively correlated with the increasing soil pH. However, it does not any correlation with leaf nutrient content for all the treatment. As a conclusion, both of treatment 2 and treatment 3 were managed to increase the peat soil pH under the oil palm plantation. However, it was evidence that treatment 2 shows better plant nutrient contents. Besides, treatment 2 also has increased the availability of the copper, zinc, and boron for the plant nutrient content. For further observation, is very important and very recommended to see the long-term effect on the soil pH, the effect of yield, peat chemistry, and its implication on the cost production. And that's all from me. Thank you very much for your time. See you in Glasgow.